request to do a retrosynthetic analysis. We chose winter 18, and I edited the one at winter 18 to eliminate everything about stereochemistry, because I promised you yours won't have anything to do with stereochemistry. So here it is. We have a useful reaction using PCl5 to convert an alcohol to an alkyl chloride. Please use that reaction when you need an alkyl halide. You see an aldehyde. There's only one way we learned how to make an aldehyde so far in synthesis, and it's using terminal alkynes. So please tell me you know this came from a terminal alkyne. The two carbons at the end used to be a terminal alkyne. 1, 2, 3, 4, 5, 6. 1, 2. Please give me 3, 4, 5, 6 as well. 3, 4, 5, 6 with a methyl on 3. Put the pink numbers on. You don't have to put the pink numbers on. They're here for you to see that the same number of carbons has to be in your next molecule, which is now your new target. I know how to make this into this, is what this arrow means. This came from this, is another way to say it. Oh, I got it on 4, you're right. Ah, good thing somebody's paying attention. If I put the methyl on 4, I would have lost a whole point on my own retro. Methyl's on 3. 3 has the methyl, 3 has the methyl. Thank you.
But you numbered them different.
Well, I hope I didn't. 6 in a row, 6 in a row, methyl on 3, methyl on 3.
Oh, you didn't put these. Oh, okay.
I had the methyl on the wrong carbon, as she correctly pointed out. Now it's time for you to think about synthesis. This was made using a synthesis reaction, where we made this bond. So you got to remember, and your limited knowledge of synthesis, you have to use a CCCC that has a minus charge and a carbon with a leaving group on it, a halogen. Please use chlorine. On this example, where you know how to make an alcohol into a chloroalkane, and I want the numbers again. Doesn't hurt. I got too many carbons. I'm glad I did the numbers. Yeah, 3, 4, 5, 6. I got to put the methyl on 3. I know I'm not done. Methyl's on 3. 4, 5, 6. So all the carbons here are here. Yeah, because then when I say I know how to make this from an alcohol, you're saying I know how to use Dr. Whitaker's reaction that he gave me for free. Not my reaction, by the way. And it's going to be the same thing. Just alcohol. And OH up there. Circle it. You don't have to circle it either. That's an alcohol with 5 carbons right there. Alcohol of 5 carbons.
Did you just bend the CL? Oh, you did?
I didn't bend anything. I ran out of room. My arrow was in the way.
Okay.
So if I drew my OH in the same direction as the Cl, it would hit the arrow. That's the only reason it's off to the side. It's on carbon, the one we called 3, right? Yeah. And this comes from acetylene, CCCC. Remember, you got to know acetylene is CCCC, or else you don't know you're finished with this thing. This is a straightforward one. Yours will be straightforward. Acetylene is really ethyne, E-T-H-Y-N-E. Okay, the retro is done because you've accounted for all of the carbons, and you ended with things in a circle because they're on our list. Now it's time to use the things that are on the list as your starting materials for the forward synthesis. So you take your CCCC and show me that you know how to make it into, let's use a different color arrow. You know how to make it into CCCC minus. Her favorite.
Use H minus, right?
H minus. I love it. Short but sweet. And then take the, use my reaction. I'll draw your OH a little nicer this time. There you go. You're happy now, right? So that's really this thing. And it needs to become OH with instead of OH, sorry, it's a Cl. And the reaction above, don't write that down. Diligently copy my reaction above. It's not hard. PCl5. It's a little fuzzy here, but on your exam it won't be fuzzy. That's a 5. Looks like it might be a 3, right? But on the exam it's a 5. Okay, so yeah, and look at the Cl. This thing's determined to make me look foolish. It moved. You guys probably saw when it happened. I didn't. It's probably when I scrolled on the screen, right? It sometimes scrolls and the last thing I did doesn't scroll. It's a glitch. All right, now I need to say that when I combine this and this, I can make this. That's not hard, is it? You're basically getting a point for a parenthesis. Bring these two things together, and you've achieved this here. Make sure. Get to 3, 4, 5, 6. Good. Which is this thing.
What if you wrote it out with the Cl minus and then pointed the arrow to the Cl and then
I wrote it out with a Cl minus. Uh-oh.
Not Cl minus. Wait, I'm sorry. I meant the triple bond with the minus.
Yes.
And then I yield it with the arrow to the C. Only has a Cl. And then under it, I wrote.
Oh, that doesn't yield this. It reacts with that.
Oh.
You could write a plus sign right there and then an arrow down to here.
Okay.
That works for me.
Okay.
You say, I made this in this step, I made this in this step. Now I put a plus sign, meaning that plus this gives this.
Is it only going to be on the product side, those two?
Yes, you got to react to two products that you made from these two reactions.
Okay.
And then I liked what I saw. I think it was somebody in this room that did this, and I liked it so much I kept doing it in class after. They said, you don't have to write the big target symbol or the word target or anything. You can go like this and just tell me how to do that. That's great. Let's do that. How do you make a terminal alkyne into an aldehyde? Yes, there's a tautomerization, and please don't give me mercury. No, mercury's going to give a ketone. The hydroboration for alkynes is HB-Sia2. Sec isoamyl twice. 2 is always hydrogen peroxide and hydroxide.
And that's because it's an aldehyde.
That's because we're going to make an aldehyde. Yeah. Unless it's an internal alkyne. We made a video on that as per your request the other day.
Yeah.
If you have an internal alkyne, it doesn't matter mercury or boron, you're getting 2 ketones. 50-50. There's a video on it. Okay, move the HB-Sia so you know it's really for this arrow here. There, beautiful. Nice. And then the next retro. Ah, it's got more steps. That's why it's 14 points. Double synthesis. You're going to have 1 and 2. It'll be 8 and 14. I'm saying right now it will be 8 and 14. But just like these two. Just very similar to what you're going to see on Monday.
That's internal, right?
Yeah, internal alkyne is your first retro step. Yes.
So that's no matter what.
It came from the internal alkyne with the exact same number of carbons. I really can't say it enough times. Students get careless on this and they just throw away a point because they'll have 1 more carbon or 1 less when they draw their alkyne, and it's just 0. You get 0 points.
It's just a rush.
I know it's a rush, but I just want you to be careful on this part of the rush. You don't have to put the numbers, just count your carbons, make sure you got 10 in a row. I mean, no, doesn't have to look similar at all. Just make sure on one side you've got 4 more carbons, 4, 3, 2, 1. 4, 3, 2, 1. And on the other side, you have 7, 8, 9, 10. 4 more carbons there. 7, 8, 9, 10 with a methyl on 8. And I'm just gonna, I don't need all the numbers. 1, 5, 6, 10. There you go. The triple bond was made into a double bond on the same 2 carbons. 5, 6, 5, 6. You're going to show me how when you do the forward synthesis. And make sure that's okay. Okay, now it's synthesis time. You know how to make either that bond or this bond. I don't care which one you want to do. It's last, because we're thinking backwards, right? This would be the last bond you made if you choose to break this one. If that's your choice, then you're going to this one with a chlorine here on a CH2 that goes to a C with a methyl and an ethyl. Plus, what kind of C triple C is it? If you write just C triple C like this, you get 0 points. Needs a minus on the end, doesn't it? No, I'll give you a point for the chloral part because that's okay, but this alkyne won't react with it if it's an alkyne. It's got to be an alkyne minus. Needs to be a nucleophile.
So one mistake makes it 0.
No, you still get a point for this and a point for this. You wouldn't get the third point for this. Well, for the things from this, you might not get points either. Yeah. Because then you got to show me how you made the C triple C, right? How did you make the C triple C? Well, what did you make it from? Don't tell me how. What was it before it was C triple C minus? It was C triple C H. C triple C H, which you can draw like this now. There's no minus, there's an H there. And the next one, keep copying that ugly retro arrow over and over. HO, right? CH2, OH, HO, doesn't matter. And I was circling alcohols with yellow and blue for the acetylene. Okay. I'll just put a yellow circle on. You don't have to circle it at all. I just know I don't have to retro that part anymore. It's an alcohol with 5 carbons.
What if it didn't say alcohol with 5 carbons?
It will say an alcohol with 5 carbons. There you go.
I'm saying, is there?
Oh, there absolutely could be alcohol with 22 carbons. Yeah, no, we're not going to do that. I like to be consistent, so you're not changing every time and say, oh my God, what's he doing now? I don't want you saying that. I want you knowing what to expect. It's already hard enough, this concept. Thinking backwards is not natural. But for synthetic chemists, it has to become natural.
This is easier than
It is, isn't it? Aren't you glad you made me do this one?
Yeah.
I think you are. All right, so now, plus the fact that we've talked about it 4 times does make it easier. You know that, right? If I started with this, you'd say, what the heck did he just do? If this was the first one, seriously, you would have said that. I don't know. Do you know what he was doing? I don't know what he was doing. But not, I think some of it's sinking in. It's good. I like hearing it. There's your C triple C minus on the right side this time. Plus, doesn't matter what side it's on. What was on this end of this carbon here? A C? I wouldn't put a C there. Wrong number of carbons. She said Cl. Did you say Cl? You need a carbon with a halogen on it for synthesis to react with a C triple C minus, just like here.
Yeah.
Carbon with a halogen on it and a C triple C minus. And these guys.
On it before. That's why I was like,
Oh, yeah. My question wasn't very clear.
yeah. Okay.
So now I want to know where that came from, and I want to know where this came from, and they're going to get circled, aren't they? Because that's one step away from being acetylene, and that gets a blue circle. And the other one one was an alcohol with 4 carbons, which is less than 5. And it moved my thing again. Or it didn't move my thing again. All right. This program keeps you awake, that's for sure. Okay. Retro's over. All of these carbons, same number of carbons that's in your target, right? Same number that's in this thing too. Let's take it from the top. I'll start down here because I see all my circles. C triple C needs to become, oh my, you're getting like 4 points for this. 2 on this one, 2 on the other one. And what's your favorite way? H minus. And then butanol, sorry, butanol.
Why didn't you put the 4 carbons in that?
4 carbons.
No, one on the right.
This one?
Yeah.
I haven't put them on there yet. I'm starting down here.
Oh,
This is the start of the synthesis, is the end of the retrosynthesis.
okay.
And let's put a divider between these so we don't get confused here. And this OH needs to become a Cl. And our useful reaction said you can do that using PCl5. And the Cl didn't move.
Yeah, you put 3.
There you go. I put a 3, like I said 5. Okay. P, wow. Failure to launch. PCl5 gives a Cl. There. Okay. Now I need those 2 to combine to make that. That's what this means. These 2 will combine to make that. So show me they have to combine. I just like being consistent. I always say parenthesis between the 2 says they are now going to meet. And they're going to make this thing right here. 4 carbons in blue attached to C triple C. And that thing here needs to become this thing here. 4 carbons in blue. Didn't get 4 carbons. Nice and close. Okay. Needs to become V. Move. Needs to become C triple C minus. How does one accomplish such a transformation? I like it. H minus. Okay, so now you're here. This has to react with this. Uh-oh, this does not exist yet. This has to react with this to make that. I need to make this first. You can't react it unless you have it.
You don't have it up there though.
I haven't made it yet. You've showed me you know you have to make it, but you haven't showed me how to make it. I need to make the CL1. So, you know, for doing the parentheses, it's going to react over here. I would start over here. I got the bond, OH needs to become bond, Cl. And chemicals already shown, OH becoming Cl, PCl5. And now these need to combine to make our, oh, so smaller. Make this. So get my parentheses going here. This guy needs to meet up with this guy. And now I'm gonna move everything up. If I'm lucky. I was lucky. Just so I can draw that molecule and see it on the retro side at the same time. And it's going to make this guy. CH2, C with a methyl. Ethyl. And then just 4 C's. 1, 2, 3, 4. That's this one. And you said how to make it. You said mix this with this. Get that. Which is one step away from our target. Tell me how to get there. She wants to use hydrogen in Lindlar's catalyst. H, well, you can't use anything. It's got to work. H2, there's 2 choices here. Here's one of them, the risky one.
I don't like that one.
I don't either. This, chances are better than 50-50 you spell that guy's name wrong because it's a weird name, right? I've seen Lindor because of chocolate. Yeah, I've seen I've seen whatever Ludner. I've seen some weird stuff that doesn't get any credit, right? Or yeah, this is your good backup. BH3 and acetic acid. CH3CO2H. You can write. I mean, BH3 and ACOH is fine too. And just remember, those are the same. ACOH, acetic acid.
Why is it sometimes use CH2, the HBCO2?
HBCO2 is to make an aldehyde from a terminal alkyne. Not relevant here. Sorry, she asked, why do I sometimes use HBCO2? That's only when I want to make a terminal alkyne into an aldehyde. And we don't have a terminal alkyne here. If our target in our previous example was an aldehyde, I would have used that reaction. Was it an aldehyde? I think it was a ketone. It was an aldehyde. It's one video and I've still forgotten what was at the beginning. All right. It was an aldehyde. We used HBCO2. Yeah, okay. Yeah. It's been a long day.
Okay, so I have another question, quick one. So you see how you did the CL? You see, like, went to the last part?
This one?
Yeah, you did that. What happened to the one to the left of it?
That's all in the retro area.
Oh, you did that already. Never mind.
Yeah, that was the thinking and this was the doing.
Yeah, okay,
Thinking about it and then doing it.
okay, you did it.
We done did it. Okay. All right. Good video, I think. I hope.
Yeah.
And then